Hello everyone, this is a 3000 watt DC-AC inverter circuit. Its job is to convert the voltage from solar panels into 220 volt AC and power household loads whenever the grid goes down. In my setup, it only runs during power outages. The rest of the time, it stays in standby mode. Of course, it can also operate continuously if you need it to. It all depends on how you plan to use it. Thank you to JLCPCB for generously sponsoring the PCB for me. I've shared the entire project with you. Go ahead and create a JLCPCB account using the link in the video description, upload the Gerber files I provided, then complete the payment and wait about 1 to 2 weeks. You'll receive 5 high-quality PCBs. Hurry up! JLCPCB is running their biggest sale of the year for Black Friday, with thousands of discount coupons available. You can save a significant amount if you register and place your order today. The PCBs arrived after 2 weeks. This time, I went with the black color instead of the usual green. The black finish looks nicer, but it does scratch more easily if you're not careful during soldering. This DC-AC module is actually very simple. The number of components can be counted on one hand. But don't worry, I've tested it thoroughly. It runs stably at a 3000 watt load without any issues. All component values are printed right on the PCB. Just assemble it accordingly and it will work. When assembling the components, you should start with the smaller parts first, like diodes and resistors. Next, install the heatsink before mounting the IGBTs. This ensures the IGBTs line up correctly with the holes on the heatsink. And don't forget to place an insulating pad between the heatsink and the IGBTs. For a 3 kilowatt system, I'd choose IGBTs rated at 75S and 600 volts. This is a 12-volt 1.5 amps power module. Its job is to step the 3 and 50 volts down to 12 volts to power the cooling fan and the driver module. You can also use a regular 12-volt adapter as a substitute. Next is the output filter inductor. For a 3 kilowatt system, make sure this inductor can handle 20 amps. Its inductance value is 2 millihachers. Along with the inductor, there's a filter capacitor rated at 4 mF and 400 volts. And here's the finished product. It's compact but incredibly powerful. Next, I'll connect it to a 350 volt DC power source and run a test. This is the 48 volts to 380 volt boost module I introduced in an earlier video. It can deliver up to 6 kilowatts at a 48 volt input. Right now, I'm running it with 50 volts input and 50 ACE from my DC power supply. The 380 volt output from the boost module is connected to the DC-AC circuit. On the AC side, I've hooked up an oscilloscope and a meter to measure voltage and power, with a lamp and a hairdryer as the load. You can see the circuit runs very smoothly and stably. The output is 220 volts with a clean 50 Hz sine wave.